Okay, we've got the ability to make music now. So now let's go ahead and make it where we can fade in those tracks because they're just starting off at full volume right now. But let's go ahead and fade in the new tracks that we want to start, fade out any old ones that may currently be playing, and control how we can switch music inside of our novel. The reason we're starting off with volume is because I'm manually specifying it when I call for the track to be played. So if I were to go ahead and take that out, then of course we don't have any sound. We do have the channel and we can see we have the track here, but the volume of the audio source is at 0. So we need to fade that in. As you might guess, this is going to be the responsibility of the audio channel, since it has a list of all of its tracks. It's going to keep track of all of them and make sure that it maintains the proper volume leveling. So let's make another function down here. Public void, actually, no, we only need a private void, and we'll call this try start volume leveling. Okay, and we're going to try to start the volume leveling. So we are going to do this with a coroutine. So we'll make a reference up above, co volume leveling, and assign that to null right now. And then a boolean is leveling volume is true if our co volume leveling is not equal to null. Okay, so if not is leveling volume, then we're going to start a new volume leveling coroutine. We'll make a private enumerator, and this is going to be enumerator. It helps to spell things right. We're going to just name this volume leveling. And so if we are not volume leveling, then co volume leveling equals our audio manager dot instance dot start coroutine volume leveling. And our audio channel also should not be a mono behavior. We should not have that. Okay, so there we are. We can start our volume leveling. Now, as for what we're going to do in here, we're going to make sure that we loop until our active track, whatever that is at its maximum volume, and any of the inactive tracks fade out completely and are destroyed. In order for us to know what's active or not, we could make a variable up here with the active track, which I think might be the simplest way to do this. We could also go in and set a variable inside of the tracks, but I'm actually going to make a public audio track and call this the active track, and make sure anything can get it, but only the channel can assign it. And it's just going to be null right now. Okay, when we play a track, we're going to play it, and if active track is not equal to track, then our active track equals track. Well, you know, in this case, that's always going to be the case. Anytime we create a new active track, we're going to make sure that that is the one that needs to play. It's if we've already got an existing track, then we need to make sure that that one becomes active. So active track equals existing track. If we find one that already exists, maybe it's not the active one, maybe we're reactivating it. So we need to reset that as the active track. Otherwise, the new one we create becomes the active track. So now we need to loop through all of our tracks and make sure we fade them in correctly. Now, we're going to need a way of setting and monitoring the volume for all of our tracks. So let's go back into our audio track, and let's just make a public float called volume, and make it where we can get and assign this value. So if we are getting the value, then we're going to return the source.volume. And if we're setting the value, which we can set it publicly, then we're going to say source.volume equals the value that we're passing in. And so with access to that, we can go ahead and loop through all of our items. So while our tracks.count is greater than 1, or our active track volume is not equal to the volume cap, which would be the active track dot volume cap. The reason we're waiting for if our track count is greater than 1, we can only have one active track at a time. So as long as we've got more than one, we've got some that are fading out. And we also need to make sure that our active track is reaching its volume. If it has not, we need to continue the loop. So let's go through each one of them. Let's start at the back of the array. That way, as we find some that reach their 0 volume, they can go ahead and be destroyed. If we start at the beginning of the array, then we'll run into errors with the loop. But if we start at the end, then we can delete and we can keep on going from there. So for int I equals tracks dot count minus 1, while I is greater than or equal to 0, then I minus minus. So we're counting backwards. And then audio track equals the tracks I. And now we can adjust the volume. So float target volume will equal active track equals track. If that's the case, if this is our active track, then we need to make sure that the volume is set to the max cap for that track. So that would be the track.volume cap. Otherwise, it's going to be 0. And now we need to move it. So track.volume equals mathf.move towards, and we're going to move from the track.volume towards the target volume by the speed. Now we defined a default speed inside of the audio manager. So we could say audio manager dot track transition speed, and we'll multiply by time dot delta time. Now, if this is our active track, then we don't want to try to move or change this value if it's already there. So if track equals active track and track.volume equals the target volume, then we're not going to do anything, and we're just going to keep going. But otherwise, we'll change that volume, and if track is not equal to active track and track.volume equals 0, then we need to remove this track. So we will actually call a function to destroy this track. We'll make this a private void destroy track followed by the audio track reference. And we're going to destroy the track. Now when we destroy this track, we're going to need to remove it from the list, so we can reference tracks.remove track if it's contained in that list. If tracks.contains track. And we also need to destroy the actual game object. Now we don't have a publicly accessible reference to that track, but we do have a private source. So if we need the object, then we can go ahead and just make ourselves a public game object and call this the root and point that to the source.gameObject, which will allow us then to say object.destroy, and we're going to destroy the track.root. And when we reach the end of this volume leveling coroutine, we'll go ahead and say CO volume leveling equals null, and we end it. Now, let's also change one small thing, and I didn't think about it till just now. We need to both add it to the list as well as set this to the active track. So that's for any new track that we create. So let's just do that all in one function. Let's make a private void called, let's call it set as active track. And this will be the audio track we'll take in. And let's check if tracks.contains track rather, if we do not contain the track, then tracks.add track. And then we'll also say active track equals the track. So then, instead of saying active track equals track, we'll go ahead and take care of all that at once. Set as active track, track. And when we add a track, that needs to actually be the existing track. And when we add a track, we also need to start the volume leveling. So try start volume leveling. So now we can play this again, and we should see the audio actually fade in. And there we go, we can see that it faded all the way to 1. And that is a little loud, so let me quiet it down a bit. I'm actually going to come in and define the volume cap as 0.5.
Yeah.
There we go. And it does that. And our volume cap is at 0.5. The reason we might want to use the volume cap is because different songs might have different loudness to them, and maybe we might want to change that volume cap. Or you can change that within a audio management system, or a DAW, or editing platform, whatever you want. Now we can check adding a new track and fading out the old one by then going to the engine room, changing the background, and here's the important part, playing the track Fractured Soul with a different audio cap, or volume cap. So we should fade out Electric Drift and fade in Fractured Soul. Okay, so
Yeah.
there we are. So we've got the first song playing. We can see it is track Electric Drift. As soon as we fade in, we should fade this one out and fade in the new song. Let me show you the engine room. Okay, so interesting issue to deal with here. We can see that we have 2 channels called 0 created, which tells me I didn't add the channel to the actual channels list when we created it. And that would really be a helpful thing to do. So in the audio manager, in the try get channel function, let's go ahead and change this line. We're going to create audio channel, we've already got channel defined above. So we'll just say that channel equals a new audio channel at that channel number. And then we can return the channel. But most importantly, between then, let's go ahead and say that channels.add the channel number and the channel that we've just created. And with that, we've got the first song playing, we click, and now we fade in the new one, fade out the old song, and now we have the new track playing. Now, we're going to add something special here, for a particular reason for me, but this might prove useful for your project as well. You'll find out why I'm using it here in a second, because I'll tell you. But let's go ahead and add, in addition to the volume, let's also specify a float for the pitch. And when we assign the volume, we'll say source.pitch equals pitch. And so in the audio channel, when we create the track, we'll also add that as a value up here, so float pitch will be available to us, and after the volume cap, we'll just pass in the pitch. And that means lastly in our audio manager, we can also add that in as a value as well. Float pitch equals 1, we'll default that to 1. And then our volume cap, after volume cap, we'll pass in the pitch. And we need to do the same thing for right up here too. So after the volume cap, float pitch equals 1. So we started the default pitch, and then just pass that in as another variable. So now we can assign the volume and the pitch to our tracks. The reason I need to do that is so I don't get a copyright strike here. So I'm going to create Stella, then we're going to create the background, and now we're going to run 2 channels. We're going to run the first audio channel to play some background ambience for rain and thunder, and then the second audio channel will be used for the music. And I'm going to now set the pitch to 0.7. And we should be able to run this in Unity here. Yep, so now you can see in our channel list, we have a rainy mood that's playing in the background, and we have this new track Calm, which is playing on channel 1. So we've got each of these that could be controlled independently from each other. So that's how we can use multiple audio sources together. So we're able to stop sound effects if they're still playing. Well, let's do the same thing and allow us to stop tracks if they are playing as well. We'll make a public void called stop track, And since a track can only have one active audio source, we're just going to pass in the channel index for this. So let's try to get the audio channel. Audio channel C equals try get channel, and we are going to create the channel, and create if does not exist should be false. We only want to get it if it exists. If C equals null, then return, because we don't need to do anything. Otherwise, C.stop track, and we're going to just leave it at that. We'll stop whatever track is running. And if we do control dot, we can generate the method in Visual Studio, then control click, and we'll go straight to it. Let's make sure it's a public void stop track, and the only thing we need to check is the active track. So let's check if active track equals null. If we don't have an active track, return, we're not doing anything. Otherwise, active track equals null. We don't want to stop the source because we want it to fade out. And then we will say try start volume leveling. So the audio's still going to continue rolling, but it's going to fade out and it's going to destroy itself when it's done. So here's what should happen. We should play the ambience and the music, and then after Stella finishes talking, we're only going to stop the music, and the ambience should still run. But what should happen is we should hear the music fade out. Okay, so we've got the calm music playing, and we will go ahead and click. Nothing happened. So what's the error? And the issue is in this one little check. Since we are removing the only active track, this loop can't technically work. So we want to check for two separate conditions. This will be determined for whatever the case may be with our active track. So let's start the first condition. If we have an active track. So if active track is not equal to null. If active track is not equal to null and our tracks.count is greater than 1, or our active track, well, this same condition that we had a second ago. Cut that and put it in here. So what we had a second ago is perfect if we have an active track. Now, if we don't have an active track, or active track is null, and tracks.count is greater than 0, because if we don't have an active track, then we want to make sure that we fade out everything and destroy all of the tracks. Okay, so we have both tracks rolling. Let's see if this works. Now let's go ahead and click the screen, and we should fade out the music, but keep the ambience rolling. So we click, and indeed, our music fades out and is destroyed, and all we are left with is the background ambience. So that's going to do it for this video, which means all that's left is that we need to now get our audio tracks able to be worked with from within the dialogue system, and that means adding a extension to our command database to mess with the audio. So we'll do that in the next part. See you guys then. Bye.